You can look at the time. We did not. Right? Difference of squares, like you could factor this into x squared minus y squared and x squared plus y squared. So could I factor that with sines and cosines? Oh. So I could factor this into sine squared r plus cosine squared r and sine squared r minus cosine squared r. And again, I'm just trying to give you a bunch of different examples of saying what kind of things do I need to look for. And factoring is that and then Chloe nicely said here that we know that sine squared plus cosine squared is just 1. So that's it, right? How easy was that proof if you just knew the fact? But the hard part is thinking what to do first. What you have to know is what you're not allowed to do. You're not allowed to square root both sides ever. You're not allowed to do anything to both sides ever. You can only work with one side at a time. You can't break up addition and subtraction under a square root. So knowing those things is kind of important. Multiply by sine squared plus cosine squared because you're really just multiplying by 1. Right? Like that's kind of weird to think about, but if you're multiplying by something that's just equal to 1, just like you could multiply both sides by x, I mean you can multiply this side by x over x if you want, because that's just equal to 1. You could just say I'm going to multiply this side by sine squared plus cosine squared, because that's really just multiplying by 1, and then you get Sometimes I don't have that answer. I just happen to have that answer. Sometimes I don't know how to work together. You have the Adele song working. I really want to do the Adele song someday. I feel the things that you want to be factor, but it's just right. So that's right. Lots of them have subjectors, like on the field, they just have and they can show PowerPoint. A lot of them have dry erase boards. Butler, I've been to a lot of talks about Butler, and they have dry erase boards. I actually not permanent, so they have they never actually. What if you change, if you don't know what to do here, what if you change the x's and y's here? Change the sine to x and cosine to y. But it's multiplication, right? What if I change this to x squared plus 2x squared y squared plus y squared? Does that help any? You back to that? Right? Like, what if I did this little this? What do I have an equal sign? Oh, it's up there. I was like, why does this equal 1? I was thinking about, like, solving for x. We're not doing this yet, but we're just trying to make all this equal 1. What multiplies together to give you x to the 4th? X squared and x squared. What multiplies together to give you y to the 4th? If I FOIL that out, will I get 2x squared y squared in the middle? That's like really hard for people to see with sines and cosines, so I really think a good strategy is changing it to x and y's, or using b's, or whatever, a's and b's, whatever you want to change it to. And then we can go back and change that I made sine x and cosine y, that this is the same as sine squared theta plus cosine squared theta. Like, is that the equal 1? That's what sine squared plus cosine squared? 1! And then really, I think this is just x squared plus y squared squared. Like, you want to write that all squared. Do that. It's amazing. It's all about manipulating the variable. Manipulate their equation. So next time you want to write 1, you can just write like this. You should give someone your phone number all in straight away. I mean, you could just have 7. Oh no, you have to change. You have to do different ones. Look, I don't really want to write the thing down. But this is what I want to say. It says, show that the equation is not an identity. So here's the greatest thing about showing something that's not true in math. To show that something's always true, like, you have to do a proof of it. You have to do it symbolically. But to show that something's not true, all you have to do is find one example that shows it's not true. What that tells you is find one example that shows it's not true. It's not an example, it's a gallery. Oh. A counterexample is an example that shows that something's false. So, like, if you ever give me a proof that says prove this is true, and you can just show a number that's not true, you're like, not true. Because I just think you should know that word. I think I have that word in one of my Pi Day songs, so maybe I want you to know what it is. This is my teaching is all about Pi Day songs and making sure that you can understand. So this is saying, show that it's not true. This is not a true statement. So think of an angle that shows that's not true. Pi force. Let's do that. So if t equals pi force, you would say the cosine of negative pi force equals negative cosine of pi force. So this is the cosine of negative pi force. Under 4 cosine is positive, like square root of 2 over 2. Negative, the cosine of pi force, is also square root of 2 over 2. But it's negative. It's not true. Oh my gosh. I just showed this was not true. All those other identities that we verified, those are true identities. They work for everything. Every angle you can think of. Not a true identity. Oh my gosh, look, that's my homework. I know, because I want you to actually look at it. You still haven't finished your other ones, or you got stuck on something yesterday. See me, we can talk about it. 21, 23, 24 are proofs. 52, 53, and 58 are show that they're not an identity. So these are all counterexample problems, so really there's only 3 proofs, 3 not proofs. So work on this. I don't know what we're doing tomorrow, that's why it's on the board, but I think we're just going on to 17. Not Kahoot. Still recording. You can't hear you unless you come up here.
Hi, Trevor.
I bet he doesn't even watch this. Now we can play Kahoot for 30 minutes.